All right, welcome everybody to What's the Point of Pointers? We're going to go over how dynamic memory allocation in C works. And we're also going to be going through an example of how you can allocate memory and how you can use references to point to your own data types in C. So the first question that we need to answer is, what is a pointer? A pointer is nothing more than an address to another variable. So in memory, you have all like these blocks in memory that can hold values. And a pointer is just a value that is actually an address for another value. So in this example, we have on the left here, I've just made some addresses. These aren't real memory addresses, but just suspend your disbelief for a moment. And then on the right, I have values. And so here I have a pointer at address 0. I have a pointer and its value is 2. What this means is that it is the address for whatever data is at address 2. So the value actually, if we were to dereference this pointer, if we were to get the value that it's pointing to, that would be 5. The value of the pointer itself is 2 because it's just an address. It's like a house number. You have the entire memory space. Each block has a number assigned to it. And that's all that a pointer is. And actually, if you print out a pointer, like when you're working with pointers, if you print it out, you'll find that it's a number. It's a hexadecimal number because the space is huge on our personal computers. The amount of memory that's available is really, really large. But it's a number. That's it. It's just an address pointing to some place in memory. That's it. And so kind of to understand why this is important, we need to ask a different question, which is, what is dynamic memory allocation? And so when you're writing a program, you don't necessarily know how much memory you're going to need when you start out writing, because maybe the user can input things from the command line. Maybe you're reading something from a file, you're reading strings from a file. You don't know in advance how much memory you are going to need. And so that's the dynamic in dynamic memory allocation. So let's say it's really just reserving some amount of memory. And so in another example, let's say we have our addresses, like this only has 5 blocks of memory. So we have addresses 0 through 4. 3 is in use. Some program is using the memory at 3, so it's not available to us. And then 4 is vacant, or let's say we've already used 3. We can call malloc to request that some memory is allocated for us. And so what malloc is going to do, we don't need to think about what memory we want. We just need to say how much memory we want. So malloc will go and will find for us memory that is available for our use. And so it's going to go ahead and allocate that memory, set it aside for whatever we want to use it for. But we need to know where that memory is. And so that's why it's going to return back to us the address, and that address is the pointer. So it's going to return back to us the pointer to the start of where you allocated your memory. And that's it. That's all there is to it. We know that we need some memory, but we don't want to deal with telling the computer like some specific memory that we want. We can tell C through malloc how much memory that we want. Malloc will go ahead and request that memory from the computer and allocate it and set it aside just for us. And then it will return to us the address so that we know where that memory is, so that we can go use it. What about, I'll get to that in a second, Rob. Yes, so this is kind of the starting point. Why is malloc great? Well, if you're using, like, let's say you're using assembly, or you're using, you don't need to, you're using something where you need to specifically say, like, I want to place this thing in this memory address, and you need to allocate the memory yourself. You don't need to know the addresses for anything when you're writing the program. Malloc is going to take care of that for you. You just say the size of the memory that you need, and Malloc is going to allocate that memory and return to you the address. So you don't need to worry about what memory is available. You don't need to worry about what memory is being used by other programs. You don't need to worry about if what memory addresses have been allocated for like stack memory and what has been allocated for the heap, which was what the heap is what we're interested in. Malloc is going to take care of that for you. So all you need to know is the size of the memory that you want to allocate, and the and you're going to get back the address, and that's why Malloc is great. Like to think of it like, imagine Malloc is a host at a restaurant. Like you go to the booth in the front of a restaurant and you say, I have 4 people or I have 6 people. And the restaurant host is going to find you a table that will fit that number of people, or is going to give you a range of, maybe you have to have, maybe the tables only sit 2 people or 4 people and you need several tables. They're going to give you a range of tables that are available to you. So if you think about it that way, Malloc is really just the restaurant host, where you don't need to specify like what table you want. You don't need to specify, like, you don't need to figure out what tables are available. You don't need to specify what tables are being used by other customers. That's the job of the host. You just say how many people you want to sit in the restaurant, and the host is going to tell you what table number, or direct you to the table that you're going to sit at, or the tables, plural possibly, that you need to sit at. So if you think about it, the host is like an abstraction for the tables in the restaurant for that seating process, and so is Malloc and friends, an abstraction so that you don't need to worry about like doing system calls to get memory directly. You can just use Malloc, and Malloc will take care of what address the memory is. Like, will give you the address and will allocate the memory without you needing to worry about it. So what are our tools for memory allocation? I'm just going to go over the 4 main functions that we would use. So we have Malloc, which will take in some size, and given that size, allocate some memory and give you the address of that memory. That's all that Malloc will do. We have calloc, which will allocate space for a number of items. So you're going to give calloc a number specifying the number of items that you want to allocate for and the size of each item. Like, let's say I want to allocate like 5, like I have 5 items. We don't really care what they are. I have 5 items, and each of those items is 5 bytes. So I could pass in 5 for the number of items, and I could pass in 5 for the size of each item, and it will allocate 25 bytes total, and it will return to me the address. The other important distinction is that it will set the value of all of that memory space to 0. With Malloc, whatever was in that memory before, if another program was using it or if you were previously using it, the values in the memory are still there. So you need to keep that in mind. But with calloc, it's going to just wipe away anything that's there, and it's going to put zeros in all of that space. Realloc, I typically don't use as much, but it is important to know. Resizes an already allocated memory block. So for example, let's say you previously allocated some memory like 30 bytes in size, for instance, or like we'll say it's like the size of 30 ints, for instance, and then you actually only need 20 ints. You can reallocate that memory using realloc by passing in the pointer and the final size, and it will give you a smaller size, and the rest of that memory will be available to the system. The other situation is like maybe you allocated some memory and you discover you need more for the same items. You can reallocate the memory. Like maybe you have something where you're trying to add to a list, and you're not using a linked list or anything like that. You just have like some list in memory, and you want to add to it more, but you already have allocated the space, you can use reallocate to make more space allocated to that pointer. And then the last thing is free. So you don't necessarily, when you close your program, or when when you're all done with some part of your program, or when you're all done with some data, you need to make sure that you free that data, because this can, if you don't, can lead to memory leaks, which is where the system doesn't know that that data isn't in use anymore. And so it just still thinks that it's set aside. So it doesn't let any other programs or your own program request that memory ever again. You need to make sure that you tell the program you're all done with the memory so that it can know that it's available to be allocated again. And so that's the point of free. Free releases any memory that you've allocated to that pointer back to the system. So let's go over a question in the chat. If I never freed the memory, is it still allocated somewhere in my computer forever? Well, no, well, not forever. Forever is a long time, but it's depends on your system. Like your operating system will probably, your operating system will clean it up for you normally. Like if you're using like an operating system, probably will implement some garbage collection, but that's not assured. It's not for sure that the operating system will clean it up for you. Like let's say your program closes or crashes or something, and will that memory still be allocated? It's possible. It depends on the operating system, but you should still free it. The other reason is, like, let's say you're using some memory. Let's say you have a program that runs for hours and hours and hours, and it's constantly allocating memory, and like you keep it open for a long time and it never calls free. Eventually it's going to fill up all of your RAM, and you're going to have nothing in your RAM because this program has just wasted all your memory, because it's allocated all this memory over and over and over again and never freed any of it. It's just bad practice. When your computer shuts off and restarts, then yeah, whatever was there should be wiped away. Dylan, to answer your question. Okay, so back to this example that I have lovingly pulled from the internet. We have calloc, and remember that the first thing that gets put into calloc is the number of items, and the second thing that gets put into calloc is the size of each item. And so, Rob, this is going to answer your question. What's the purpose of sizeof? Sizeof is just a convenience function that you can pass in a data type, and it will return the size in bytes of that item. So for instance, in this example, this size of int is going to resolve to 4 bytes. So you're allocating 5 items of 4 bytes each, and so you're going to have 20 bytes allocated total, because you're going to have 1, 2, 3, 4, 5 blocks, and each of them is going to be 4 bytes each. And then what's going to be returned to you is a pointer pointing to the address of that first byte. Why would I not just put the size though? Rob asks. Like, I know that char is 1 byte, for example. That's true that you might have memorized the data type, like the sizes for maybe some primitive data types, but when you're making your own types, and we're going to go over that in the actual coding portion, you may have like a struct that has many different pieces of data in it, many different variables in it, and you don't want to have to do the math to figure out how big that struct is every time if you're defining it as a data type. So this makes it much more convenient. Like with int, it's pretty easy to remember. With char, and I'm pretty also, Rob asks, is size underscore t just an int or something else? I'm pretty sure that it is. I'm pretty sure at least they're interchangeable. So it is an integer value for sure. I think that you can pass in an int and it will get cast to a size underscore t, but I'm not, I'm not 100% sure. Okay, so back to our example, let's just finish this up. So calloc, again, we're passing in 5 for the number of items and the size of the item, each individual item, and it's going to reserve that amount in memory, and it's going to pass us the address to that memory as a pointer. That's all. So how about for free? So going back to like continuing off of that previous example, let's say you do some stuff with that, the memory that you allocated, and then you're all done with it. You need to make sure that you free it. And all that freeing is going to do is take those 5 blocks of memory and it's going to release it back to the system. So it's going to, maybe a trash can is not the best visual, but it's making it available again to the system, so that if you call calloc 5 sizeof int again, it's possible that you could get some of that same data again, some of those same memory locations. But if you never free it, no matter how many times you call calloc the same thing, you're never going to get that same address space. It's going to be wasted. It's going to never be available to you or any other program until your program stops or crashes and it gets recovered by the operating system. So that's all of the slides and information. I'm going to stop here for a moment and ask, are there any questions? You can feel free to unmute yourself, or you can place it in the chat if you prefer. It looks like there are no questions. Oh, okay, Alexis asks, when do we know when to use pointers instead of other ways to store memory? Okay, this is a good question. So I guess what you're referring to is when you say other ways to store memory. So one way I guess you could be thinking of is just declaring you need an int. Yeah, so use static allocation, you know that you're going to need 5 ints or something like that. Or yeah, okay. So that's when you know for sure when you're starting the size of something that you're going to be using, or the amount of something that you're going to be using. So let's say that you're making a really simple game or a really simple calculator for the terminal. And you know that you're only going to ever take in 2 numbers, and you're going to be working with 2 doubles at all times. Then it's okay to just statically allocate those. You can just say double whatever in your double operand in the code, and it gets statically allocated. So yeah, I guess a calculator would be a good example of a practical program. But when you don't know how much data you're going to be working with, so let's say today we're going to be loading in data from a file. I've got a list of foods and restaurants in a file, and there could be as many restaurants as I want, as many different foods as I want. You don't know when you're writing the program how many different restaurants you're going to be working with. So that's why dynamic memory allocation is important, because you can allocate as much memory as you need. If you know for a fact that you're only going to be working with you're going to be taking in a string from the terminal, and you're going to say oh, it's always going to be less than 100 characters or something like that. When there's hard limits on the amount of memory you're going to be using, or the number of variables or instances, then it's okay to statically allocate the memory. If you don't know, then you need to use dynamic memory allocation. Does that answer your? Okay, well, when should I do in and okay. I don't think I understand your question. I'm sorry. Oh, I get it. I get it. Yeah, so again, when you know the size that you need in advance. So like if you're scanning in something and you're just going to say like the maximum size is 100 or whatever, then it's okay to just use the static allocation, which is just the bracket notation. That's okay. If you like don't want to say like some maximum size, and you don't know how much you're going to be taking in, like let's say you are reading from a file and every other line of the file says the number of characters that are on the next line, then you would need to use um, dynamic memory allocation probably. The other important thing is dynamic memory allocation allows you to like you have the pointers, you can reference it from elsewhere. So like you can um, you can pass things by reference instead of by value. So like if you have two structs and they both need some sort of information, like let's say you have an array of like stocks, and it has a symbol and it has a value in dollars. And like every user of this program is able to pick their favorite stocks and it's going to keep a record of them. Well, instead of having to constantly be updating all of the values because the price is going to change every second or so, instead of having to update all of the values for all of the actual values that people have in their favorites array, you can just use pointers to some array of stock values, and you're just updating that array. And then because everybody's referencing it by pointer, they're able to get the value without you needing to update it. Like if you have 10 users and you use static memory allocation, and you're not using pointers, and everybody has 10 stocks, then you have to update 100 values. But if everybody has, like, let's say the same 10 favorites and you have 10 users, then you only need to update 10 values because they're all pointing to those values. Maybe it'll become more clear once we actually start the programming too. So let me pull up. I'm going to make a new folder. And then let me share my screen. Okay, can everybody see yeah, you can see my VS Code instance. So we're going to be making a really simple application to demonstrate memory allocation and freeing. So I've made this file. I noticed, that I really think that the next frontier for food delivery applications is the terminal. Grubhub, it's on your phone, it has a website, but can you order from the terminal? And the answer is not yet. So we're going to take the first step towards doing that today. All we're going to be doing is loading in some data of like restaurants and their different foods and prices. I just want to demonstrate the memory allocation and deallocation. And we're just going to be doing it in the terminal. So I have some data. Let me pop it in the chat. Oh, it's not working. I just have a text file with some data. One moment, let me load it into the chat. Okay, so I sent some data in the chat. It's just a text file, and let me open it up here. Okay, so what I'm doing first is I'm allocating, I want to read in all of these different menu items. And the menu items have a name and they have a price. And the first thing in the file is going to be the number of food items that I'm going to be reading in. And then I also want to associate these items with the restaurants that serve them. So after we read in all of the items, the second thing that we're going to do is read in the different restaurants and link those restaurants through pointers with the items that they serve. So on line 18, after we've read in all of the different foods, on line 18 is a number indicating the number of restaurants we're going to read in. And then it's the restaurant's name, the number of items on their menu, and the names of the items, but not the prices. We're going to have to associate this data with the data we've already read in. I don't know if tandoori bowls open anymore, but they're really great. I hope they're still open. And so make sure you go there. I'm just gonna like talk about my favorite restaurants for a second. Domochibi is a place that opened up in Waterford Lakes, and they have really, really delicious ramen. So make sure you stop by there. Pom Pom's Tea House is on Bumby. It's like more in downtown, but you have to try their Thanksgiving sandwich. And Dr. Simlansky, if you have him, will recommend the same thing to you. They give you the sandwich and also some gravy to dip it in. It's really, really great. And then also Jowry's ice cream. I hope that I'm saying their name right. But Jowry's ice cream, they make bubble waffle ice cream. So really, really delicious ice cream. And then it's on like this waffle, like it's sort of like egg-shaped bubbles in the waffle. It's really great. Anyway, that's just my like one moment to talk about my favorite restaurants. So the first thing we need to do is really define the types that we're going to be working with. So I'm going to make a file here, and I'll call this meal service .h. So this is a header file, by the way. This is just where we can declare some types, and also if you wanted to write your function declarations here, you can. So one thing that we're going to need, if we look at the data, we can see that each of these has a name and also has a price. And so the name, that's clearly going to be a char array, and the price, it looks like we can treat it as a double. So let's make a type def for this. So, well, first let's just make our struct. So struct, and we'll call it items, and it's going to have a char star, which is the name of the item, and it's going to have a double, which is the price of the item. And then what we can do, because we're going to be using this in a lot of places, is we can make this into a type definition by using the type def keyword, and we can give it a name. We'll call it item. And so the second thing that we need to work with is these restaurants. So let's again figure out what do we want those restaurants to have. Well, if we look here, all of the restaurants are certainly going to have a name. They're going to have a menu, but we can use the type that we've already created. We can make an array of item pointers in order to point to the items that we want. That way, like from the restaurants, we can also get their price. And probably for convenience, we'll want to say like the number of items on their menu. So let's start with our struct, and we'll call it restaurants, and we'll give it a char star name, of course. And then we can make an array of items or a pointer to pointers. So here's one for a pointer, here's two for pointer to pointers. Menu, and then an int for the number of items. Is everybody okay with what I just did here? with this item star star. So let's think about this for a moment. We know, because all the time we're using char star to indicate like strings. Well, this really is just a pointer to some memory space of characters. So really what this looks like in memory is like if there's a name like, you know, A, B, C, D, and then it's also going to have a null terminator. So this is what this is going to look like in memory, right? So we have a pointer to this first value, and then how C works is that it's going to continue reading characters until it hits this special character I've made here called the null, until it reads a null value. So this is a null terminated string. So it knows that given the address to the first member of this array, or the first part of the memory, the first block, keep reading until you hit null. That's how we deal with strings. What we really like is for this to be like, we'd like to be dealing with pointers of items. So we'd like to have like an array where we can have addresses to the different items that we're allocating. And that's what we're doing here. Let me get rid of this. So we're not dealing with like a pointer to an item. We're dealing with a pointer to an item. Or in other words, we are dealing with a space in memory where there are many pointers to many items. That's what this star star means here. So 1 star, this would be a pointer to a menu item, and then like we would expect that in memory this would actually be the item. But star star means a pointer to a pointer, meaning that we want to go to some memory, and then from there we want to be told where else to go in memory in order to get to the actual items. So that's why we have this star star. And then I'm just going to make this into a type so that we can use it in the future. And we'll call it restaurant. Okay. Oops, I forgot a semicolon. All right. Is everybody okay up to this point? If there's any questions, feel free to interrupt me or put them in the chat. Okay. So let's get started with the code part of this. So let's make a new file. We'll call it meal service.h. Oh, sorry, .c. Whoopsie. This is our actual C code. So the first thing we need to do is we need to import that header that we previously made. So we're going to use the include statement, and then we can just do meal service.h. And by the way, if you don't know, this is a preprocessor directive. That's all that means is that when you compile your code, the preprocessor directives are read before your code is compiled. And all include does is it literally copies and pastes whatever's in this file at the top of your code. That's all it does. The same thing, by the way, if you do like define, if you've ever seen that, and you have like, you know, num values or something, and then it's 10 or whatever. Define, all this does is before your code is compiled, the preprocessor goes through your code and finds any part where it says num values and deletes that and replaces it with 10. It's literally just doing find and replace before your code gets compiled. That's just a fun fact that I want to give to you. Okay, so let's think about like, what do we want our code to actually do? So let's write our main function first. So, and then so the first thing that we want to do is we want to get some way get some way to read from the file. So that's the first thing we want to do. Then once we get some way to read the file, what we'd like to do is we'd like to read in the number of food items. That's the first thing that's at the top of this file, right? And then the thing we'd like to do after that is we'd like to actually read in all of those foods. Because once we have the number up here, we can go through and we know that there's going to be 8 sets of item names and item numbers, okay? So we'll read in all of the foods. And then after we do that, the next step is we want to get the number of restaurants. So, because looking at that, after our birthday cake addict bubble waffle, which is my favorite bubble waffle that they serve, we have this 4 here, which indicates the number of restaurants. So we want to be able to read that in. So get the number of restaurants. That's something we want to do. Then we want to read in the restaurants. And this is where it gets a little bit more tricky because we only have here like the names of these foods. Like we know that tandoori bowl serves chicken tikka masala and lamb korma and butter chicken, but we want to associate those with the values, like with these item values here, right? And so we can't just declare new values because we don't have the prices at this point. So we want to be able to, using the pointers that we've allocated when we were reading from this part of the file, we want each of these restaurants to have the pointers to their food items. So we want tandoori bowl to have 3 pointers. We want it to have the pointer to the food item where it's chicken tikka masala. We want it to have the pointer to the food item where it's the lamb korma. We want it to have the pointer to the food item where it's butter chicken. Okay, so we're going to read in the number of restaurants. And then in here, what we need to do is like for each of the restaurants, get the pointers to their food items. Okay, that's what we want. Because remember, when we made this type def here, we said that we wanted pointers to food items. We wanted pointers, or we wanted an array of pointers to food items. That's what we want with the menu. Is everybody following so far? By the way, you can use the reactions feature. Like you could give a thumbs down or something like that. It won't hurt my feelings if you're like not okay. Or if you need some more information. Okay, cool. So kind of here we've written out our roadmap. We have our roadmap for what we want our program to do. So let's start with the file IO stuff. This is not super difficult in C. C gives us some a super helpful header that we can pull from. So we need to go up here, and first of all, we should probably include the standard library. And we should include the standard io.h. And this is going to allow us to read in from a file. So the first thing, in order to read in from a file, we need to get a file pointer. So we're gonna get, like, we want to call fopen, and we want to pass in the path to our file. So if it's in the same directory, which it should be, it's just in data.text over here. So you can just put in data.text, and we're going to read so we can put in the mode as R. What's this going to do? This is going to return to us a pointer to like where it is in the file. Yeah, so we're going to get some file pointer, and we'll call it FP. We need to actually declare it though. So actually, oh, we could just give the type here. So file star FP. So we have this file pointer, FP, and we can open the file. So then we can, the first thing we need to do is get the number of food items. So let's declare at the top, let's declare some int num items. And then we'll go here and we'll do fscanf. Fscanf is just a way we can give it a format string. So we'll pass the file pointer. We'll give it a format string, which is the just saying what is the format of the data that I should expect. And we're getting an int value, so we should use %d. This is the same if you're using printf. And there's also a new line, so make sure to put \n to let it know that actually, like, when it gets to the end of the line, it needs to know that it needs to read in that line and go to the next one. And then we need to give it a place to put the value. Now you might want to do this, num items, right? This makes sense. Like, that's the place to put the value. Let's try and compile. So, by the way, I'm going to use GCC to compile, but you're welcome to use whatever you're comfortable with. I know probably you're using code blocks if you're in CS1. So GCC is just the command to compile, and I'm going to pass in the file. So meal service C. That should compile it. Oh, and it's giving me a warning. So the format specifies type int pointer, but the argument is type int. Because this, we're just trying to pass in some value. What fscanf wants is not some value. It wants to know an address to where to put our value. So we've allocated the memory up here. By the way, if you're doing int or something like that, you don't need to do this. You don't need to do malloc like sizeof int. You don't need to do this. For primitives, you don't need to allocate memory in that way. But what we do need to do is, instead of passing the actual value, this is going to resolve to, like, if we were to do this, int num items equals 0, what we would actually be passing in is 0. And this is not useful information, because what we would like the program to do is to replace whatever value is inside of num items with the value it's reading in from the file. So instead of passing in the actual value, we're going to pass in the address. Well, how do we do that? In order to do that, we use this ampersand. And this is instead of passing in the value, we're passing in the reference. We're passing in the address to num items, so that when all is said and done, we go ahead and do printf, and we do %d, and we do, just to make sure that we're reading it in properly, num items. We do this, and then I'm going to run my program. Whoops. Great. So we're reading in 8, which is the number of food items that we expect. Okay. So first part accomplished. Mission 1, check. So now, actually, mission 1 and mission 2 check, because we're reading in the number of we found some way to read from the file, and then we're reading in the number of food items. So then the next step is we need to read in all of these foods. So what I'm going to do is I'm going to make a couple of functions, so that we're not writing all of the logic for allocating that in our main method here. So the first thing I'm going to write is something to actually read in the items. So let me make a function here. I want this function to return the whole array, the pointers of the items. So I'm going to do item ***, and then read in items. And what am I going to pass in? Well, the first thing I need to pass in is the file pointer. So I'll do file *fp. And then I should probably pass in the number of items. So I'll pass in num items. Okay. And what I would like for eventually, the reason why I'm saying this is, what I would eventually like to do is I would like to be able to write it like this. I would like to be able to do an array of item pointers, items, and make that equal to read in items and have it return by passing in the file pointer and the number of items. I would like for this to do all the logic of reading in those items. So let's figure out how we can do this. So the first thing we need to do is we need to actually allocate space for these items. And this is kind of addressing, I think Alexis asked her question, why do you use malloc or calloc instead of just saying like, oh, I want like this, an array of this size? And it's for precisely this situation where we don't know when we're writing this program, the number that's going to be passed, the number of items that are going to be passed in. So let's start by allocating memory for it. So item star star items equal to calloc, and the number of items, that's our first argument, and then the size of each item pointer, that is. So we'll do size of item star. Great. So this is going to allocate the size of an item pointer times the number of items that we have. And it's going to, essentially, it's going to be making our array of pointers. Notice this does not actually allocate the space for the items themselves. We have to allocate, like we have 8 items. We've just all we've done is we've allocated like 8, like we've just allocated 8 spaces in memory, and we need to fill this like with the addresses. So this would be addressed to item 1, and then this would be the address to item 2, and so on. These item numbers being like the order that we're reading them in, by the way. So we've just allocated space for addresses. We have not actually allocated space for the items, and that's important because look, our items have names which need to have space allocated for them, and doubles which need to have space allocated for them. So that's kind of an important distinction to make. So let's start with reading in our items. So I'm just going to make an int to iterate on. And we have 8 items. We're going to need a for loop because we're going to be doing the same thing every time. We're going to be reading in 1, 2, 3, 4, and so on. But we're reading in the same thing. We're going to do get the name, get the price, get the name, get the price, get the name, get the price. So that's why we're going to be doing this in a loop. So I'm just going to say the max size of the name is going to be 100. And then I'm just going to say I'm going to allocate a price so that we can read it in. And then I'm going to make a for loop. So for int I equals 0, I is less than num items, I plus plus. Okay. And then I'm going to be using fscanf. Now I'm going to be using a little bit of weird syntax in the format string, but I'll let you know why in a second. So fscanf, and then I'm going to be passing in the file pointer, and then I'm going to be writing in this format string. So, oops, wrong. And this is just going to allow in white space except for the new line. Because we have a problem here where if we just did like %s, it would read in chicken and that's it. But we wanted to read in until it gets to the new line. We want it to read in chicken tikka masala. So that's why we're using that format string. I'll copy and paste this into the chat, just because this is a little bit, you know, probably not something that you have covered in CS1. And then I'm going to say that I want that data to be populated in item name. Now, why? One second. Let me also fscanf. Let me read in the data for the our price. So this is much easier. This is just going to be %LF is like long float. If that's for double. And I'm going to be passing in the price, the address. But why do I have to do an ampersand here, but I don't have to do an ampersand here? That's not fair. Well, the reason is because this is actually shorthand. This is actually going to be a pointer. This is actually a pointer. This is actually an address. We're just like allocating this memory on the stack. So the C is going to allocate this for us, is really the answer. And it's going to be, this is actually referring to a pointer. Or an address, that is. This, we need to specify that we want the address and not the value. But this is always going to be the address. Okay, so now we want, I'd like to do something where I've got this items array, right? And I'm iterating through the array. That's the whole point of making this like this loop. And I want to somehow like make this the pointer to the item, right? I want to allocate some space for this item, and I want this items I to be the pointer to item I. So let's make another function where we're going to construct the item, right? So we'll call it make item, and I'm going to be passing in the item name and the price. And I would like for this to return a pointer. So we need to make a new function. By the way, if you're not writing function declarations at the top, you do need to make sure that you write the functions in the order that you're going to call them. So we'll say item star. I want an item pointer, not a pointer to pointer, a pointer to an item. And I want to do make item. And I'm going to pass in a char star item name, and I'm going to pass in a double to the price. And here inside of this function, this is where I'm actually going to allocate space for the item. So item star item, and then I'm going to use malloc size of item. So what's happening in this line? Well, I'm saying I want a pointer as item star, 1 star pointer to an item, and I'm allocating that the size of an item in memory. And so what's this size of going to do? It's going to go look at the data type, and it's going to calculate, well, how much memory needs to be allocated for a character pointer and how much memory needs to be allocated for a double, like how much for each of these, for this data type, how much space needs to be allocated. That's why we use size of. And this is an example, by the way, Rob, of what you asked, where like, what's the point of using size of? Why not just figure it out yourself? Well, because it's really annoying when you're making your own data types. Okay, so now what do we need to do? Well, we need to get the item's name and like set this, you know, and like get, oops, item name, and we want this to get like a pointer to the name. So we have this char star here, but this is actually going to change because we have it in this loop. We can't do this. This is not something we should do. And the reason is because you see inside of this loop where it's been allocated, it's going to change every time. And remember that this is a pointer. This is a pointer to a place in memory. So that means that this is every time this loop runs, the value that this is pointing to is going to change. And that's not something that we want. We want to make sure that this name stays the same throughout the program. So I'm going to use a function duplicate, string duplicate, and I'm going to pass in item name. Yeah, there we go. Okay, and what's this going to do? Well, this is going to allocate some memory for us. And I'm going to pass in a pointer to the item. And I'm going to pass in a pointer to the item. And I'm going to pass in a double to the price. And here inside of this function, this is where I'm actually going to allocate space for the item. So item star item name, and I'm going to pass in a double to the price. And here inside of this function, this is going to allocate some memory for us. it's going to copy the string, the value of the string into that memory, and then it's going to return the pointer to that string. So it's calling malloc and it's calling string strcpy string copy for us, and it's going to return to us the pointer to that string. And that string will not change because now we have a different pointer from this pointer here. This pointer is going to change every time this loop runs. This pointer will stay the same throughout the program, which is what we want. Okay. And then we want to get the price. This is much easier. We can just do price here. Why do we have to do one? We have to worry about it getting changed to the other. We don't. Well, because we're passing this by value. This is a primitive data type, so we can pass it by value. And it's just going to set this value equal to that value. So we don't need to worry about it getting changed or something like that. Very nice. Okay, and then we can return the item that we made. So now let's go to our read in items thing, and then this make item should work, right? Because we've abstracted away, we've made this logic for creating an item. This function is going to construct an item for us and return the pointer to it. So that's really convenient. That's what we want. So let's just take a minute to test that this is doing what we want. So I'm going to make a function called print items, a print item, just so that we can go through and make sure that these are getting read in properly. So let's, it's going to take in an item pointer. And I'm going to just use printf. And so our string, we'll use a new line and say %s for the string, and then we'll put a colon, and then we want it to print out the price, so we'll do %lf. And what will we pass in? Well, we're getting the item here as the parameter, so we'll pass in item name and item price. Excuse me. All right, great. And then let's make another function called print items, just for our convenience. And we'll put in item items. So this is an array of items or a pointer to many pointers of items. And then we'll make a for loop. Oh, we should also probably pass in the number of items. And then we'll make a for loop here. Oh, I see what I did here, but this is going to fail. I'm just used to doing that. Make sure on line 19 you delete the int there that I put in the for loop. I'm used to Java where that's okay. So we have an int, so we'll do our for loop. So I is equal to 0. I is less than num items. So we're going to iterate through the items array. I plus plus, oops, plus plus. What's this? Okay. And then we'll call print item, and we'll pass in item, and we'll get the ith item. So the first time this will print out whatever is in the, oopsie, that's items plural. So the first time this will print out the 0th item. The second time this will print out the first item. The third time this will print out the second item, third item, and so on. Sorry. Counting's hard. Okay. So let's stop here and check our work by going down. We got this read in items. Let's see if it prints. So we'll do print items and we'll put in items, and hopefully this works. So I'm going to compile my code. Uh-oh, we've got some errors here. I see. Implicitly declaring library function. Okay, and it's on line 8. Yes, I forgot to include the library, the header for that library. So we need to make sure to include string.h. So because what this error means is it's saying like, why are you making up a function that doesn't exist? When really it does exist, I just forgot to include it. Okay, so that's fine. And then, oh, too few arguments to call, expected to have one. Yes, that's correct, because this should take in items and then the number items, num items, because we passed in both of those things and we declared the function. Okay, let's try again. One warning on line 25, non-voiding function does not return a value. Oops, yes, yeah, that's a good catch. Thank you, compiler. I forgot to return. We made this items array here. We need to return it. And if you don't write that, then when we go here in main, it would say like, oh, well, there's this, it would say that this is empty, right? So that's good. Good catch. Okay. So let's try running this. Okay, hooray! So it printed out all of the items, chicken tikka masala, and then the last item was birthday cake, attic, bubble, waffle. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's 8 items. Hooray! Let me pause here. Does anybody have any questions? Or are they at the point that I'm at? Does anybody have any complaints? I'll pause here for a moment. Feel free to unmute or put in the chat your thoughts, or just thumbs up if you're good. All right, okay. All right, we'll continue then. All right, so we have accomplished our mission here. Read in all of the foods. Now let's get the number of restaurants. Well, this is really easy. We already did this. So all we need to do, we'll just make another int up here. And we'll do fscanf again. And we'll pass in the file pointer. And we'll pass in, remember, our %d, and then the new line. And then we're going to pass the address of num restaurants. So we're just doing the same thing we did above. Let's just print f this real quick to make sure that we're reading it in properly. And let me compile and run. Okay, and yes, this is 4. That's correct. There are 4 restaurants. So we are reading it in properly. Cool beans. So now let's get to the second hard part. This is kind of the big challenge, is we need to read in the restaurants. So I'd like to do the same thing that I did above, where I have this restaurants, you know, ***, and restaurants. And I'm going to make some function like read in restaurants and have it take in the file pointer and the number of restaurants. And yeah, we'll start here. So this is what I want, right? Let's start making that function. So it's going to return an array of restaurant pointers. And what did we say we wanted to pass in? Well, we wanted to pass in the file pointer. And we wanted to pass in an int num restaurant. Okay. So this is, we'll start with this. And so what's the first thing that we need to read in? Well, if we look at our file, the first thing we need to read in is like the name of the restaurants, right? Because we have this tandoori bowl, we have the number of items, and then we have the items themselves. So let's start by allocating space. And then remember, we want it to be the size of a restaurant pointer. Okay. So what's happening here? Well, we're doing really the same thing that we did with the items. We're just using calloc, passing in the number of items that we want to allocate, the size of those items, and then we get our array of pointers. And remember, this is an array of pointers, not an array of restaurants. Is our responsibility, just like we allocated for each item, we allocated the space for the item. It's our responsibility to allocate the space for the restaurants. So, okay, well, here we are. So we're going to need to read in a char array name, and we'll just say that that's size 100. And yeah, we'll start here. So let's start by making a loop, because remember, we need to loop through these restaurants. So we'll do for I equals 0, I is less than num restaurants, I plus plus. And we want to here, here we can allocate the space for it. So we could either allocate the space here. Oh, Rob says, so is the standard way to loop over an array just to pass the size around everywhere? I guess it's the safer way. You can also do like size of, if you know the size of the items, you could do like size of array over size of items, but I just was preferring to pass in the number just for the purposes of this. So we need to do the same thing we did previously, where we need to make a function to actually construct a restaurant, right? So what we should do is do restaurant star, make restaurant. And what do we need to pass in order to make a restaurant? Well, looking back at our data type, we need a name, we need the number of items, and we need the items themselves. So this is where we're going to hit a snag, but I'll get to that in a moment. We'll make the name, we'll make int num items, and we'll make the item star menu items. And what do we want to do here? Well, here we want to allocate the like restaurant. So this, we're actually allocating the size of the restaurant itself, not the, and we're going to get back a pointer to that restaurant. So, but we want the full size of the restaurant. And then we need to allocate, or we want to do the same thing where we assign the name. So restaurant name is going to be string duplicate name here that we're passing in, and restaurant num items is going to be equal to the num items that we're passing in. And then this items array, it's already been allocated if we're passing it in. So we can just, this is okay to do. Restaurant menu is equal to menu items, because we're just going to take this pointer to pointers and we're going to put it in this slot that expects pointers to pointers. And then we're going to return the restaurant that we just made. But here's the thing. We have a problem where we have these names of the items, and we need to associate them with the items we've already created, right? Because we need to construct this menu items pointers to pointers. This would, thanks, Leonardo, for the compliment. Actually, Dr. Gerber said he's hoping that we can do this same workshop earlier in the semester if we do it in the future. So yeah, but unfortunately, just the workshop schedule, it didn't work out this semester. So sorry this isn't coming before your assignment one. I know, actually, I was like, what I was thinking of how to make this like this workshop, I took a look at your assignment one to see what were the kinds of things that you needed to do. Yeah, sorry about that. But hey, you're going to be so prepared for assignment two. Okay, so sorry, I got a little bit confused. Okay, here we go. So we're going to read in these restaurants, but the problem is we actually need to get the, we need to associate the items with their pointers in the array we've already created. So here's what we're going to do. We're getting in the name, so that's okay. Yeah, hold on one second, sorry. Okay, so let's get in the name of the restaurant. So I'm going to use fget_s this time because I was actually, let me do the solution that and use the same syntax, and this should work. So we're going to pass in the file pointer and our, oopsie, that's not what I meant to do. And I'm going to use the same format string that I used before. I want, go, S, and there we go. So that's the format string that we're going to use. And we need to tell it where we want to put it. We want to put it inside of name. Okay, so we have this name here then, that's good. And then we need to get the number of items, because remember on this sheet, you had the name of the restaurant and then the number of items that they served. So let's read that in next, because we're looping through for each restaurant. This outer loop, you can think of it like it's going to loop through all of this up to Domu Chibi. And then the next iteration, it's going to loop through Domu Chibi up to Pom Pom's Tea House. And the next one is going to loop through up to from Pom Pom's Tea House to Jowry's Ice Cream. Then it's going to loop through to the end in our outer loop. Okay. So let's get the number of items. And we're gonna pass in %d. And remember, we want to pass in the address to the num items int that we created. Okay, so now we need to associate our items. Now as we have the number of items, and we need to figure out what to do. So there's a couple of things that need to happen. So first of all, let's go ahead and allocate space for the items array for the menu items. So I'll do item ** menu items and do calloc, and I'll do num items, and I'll do size of, and remember we want to pass in an item pointer. We want to pass in a pointer to an item as the size. So now let's loop through, because this is essentially what we want to do. We have the number of items, and for each item, we want to find, we have the names, And what we'd like to do is for each of these names, like for chicken tikka masala, we want to find the pointer. Then for lamb korma, we want to find the pointer. Then for butter chicken, we want to find the pointer. Then we have an outer iteration of that outer loop, and we want to find the pointer for tonkatsu ramen. And then we want to find the pointer for shoyu ramen. Okay, so we need to make another loop. And I'll declare another one up here. Num items, and then j++. Oh, speaking of things that start with J, J Pedal is another great restaurant to go to. They serve crepes. So I thought it was really good. So let's get in the item, name of the item. Oh, you know what? I might use fgetS here because I remember it was having trouble moving to the next line. So, but anyway, we want to get the item name, and then we want to find the pointer which matches that item name, and then we want to assign that pointer to its place in the array. So getting the item name, I'm just going to use fgetS here, name. I'm just going to pass in a maximum size again of 100 and fp. fgetS, what it's going to do is get 100 characters or the new line, whichever comes first. And I think I'm going to do that here too, because I remember having some trouble with this format string. So name and 100 and fp. Oh, I see what I've made a mistake here. This needs to be, by the way, item name, right? Because we have a different item. So, and we need to also declare that. Okay, there. So now it's happy. And then how are we going to find the pointer? So what I would like to do is I really would like to do like menu items and then J and then equals like some function get item pointer. And I'd like to pass in the items and then I'd like to pass in the name, the item name, and then I'd like to pass in, like, we'll need the size of the array. So item array size. But one problem is we didn't pass these in when we originally created this function. So let's add those real quick here. So we want item star star items and int item array size. This is as a parameter to the function. And then we'll just go down to where we called the function, pass in those things. So items and then num items, right? That works. And then the red squiggles should go away. Oh, that should be restaurant, not restaurants. Sorry about that. Okay, so here we are. We're going to get the menu items. And then we would like to yes, okay. So now we have everything we need in order to create our restaurant. So let's, oh, we forgot to allocate memory for the restaurant. So I'm going to do that real quick here. Actually, we can just do that like that because we're going to allocate, we already allocated memory in our function. Sorry about that. So actually we don't need to allocate memory. That was just my mistake. I made a mistake in my notes. Sorry about that. So now what we would like to do for the grand finale, we would like to do restaurants I is equal to make restaurant, and we want to pass in the name, and we want to pass in the number of items, and we want to pass in our menu items. And then we want that assigned there to that index. And then what we would like to do is return the entire array. So outside of all the loops, we'll do return restaurants. Okay, cool, cool, cool. So I think we've accomplished what we set out to do, but let's add some functions for printing out restaurants so that we can see if what we did works. So we'll do, I'm just going to do the same thing pretty much with that we did with the item. And I'll add a new line and %s. And then we're going to do restaurant name. We want to get the name, and then we want to print all of the items, right, that the restaurant has. So we'll do print items. We've already made that function. Might as well use it. Restaurant menu, and yeah, restaurant num items. Okay, great. And then I'm just going to add in a new line. And then just like I did before, I'm going to make a print restaurants plural function that's just going to be a loop. Make a variable there. Oopsie. Ooh, I misspelled the data type. Sorry, remember it's restaurant ***, not restaurants. My mistake. And then we'll just call print restaurant and just pass in restaurants I to print out the I restaurant. Okay, so here we are. Now let's see if what we did works. Okie dokie. So I'm going to compile. And I have an error. Implicit declaration of function get item pointer. Oh, I probably did it. It's because I probably. I see. Yes. So I said, oh, I want to make this function called get item pointer, but I never actually wrote it. Whoopsie. Sorry. Let me write this function. Let's write this function. So remember, we want to write this function get item pointer, and we want to pass in these things, and we want it to return the pointer. So here, what we'd like to do is we'd like to return a restaurant, and get item pointer, and we'd like to pass in, remember, the items array. So and then the name of the item and the number of items. Okay. Now, how can we do this? Well, we can do we can use string comparison in order to iterate through the item array and find the one that matches. So that's how we'll solve this problem. We'll just do I is less than num items, I++, okay? And then in here, one problem that we might experience is that the new lines, they might not quite be the same because like it, well, yeah, let me write the comparison first and then it might make a little bit more sense. So we'll do if strcmp, which is string compare, and then do items I, because we're iterating through the name, and then do name matches name. If those match, this is going to return 0. So this should be equal 0. We'll want to return items, items I. And if none matches, we can just do return null, but in our situation, that's not going to be the case. However, we might end up with a situation where we're trying to compare like Tandoori, and then because we're reading it in from the file, it might end up having this new line character on the end, or a white space character. So real quick, I'm just going to add a line here that that makes sure that those new line characters aren't there. So this doesn't have anything to do with pointers, but I'm just going to make a new like my name and do a duplication of name. And then I'm going to do my name strc spn. And then I'm going to do my name and I'm going to set that value to 0. Okay. All this line is doing, you really don't need to, and I'll even copy this in the chat because this is really like ancillary to what we're doing. This is just removing this new line character from the string. And then we need to, instead of comparing it to name, we need to compare it to my name, that new variable we made up here. Okay, and now I think after remembering to do that part that was very important, I think that this should compile. Well, warnings, okay, so that's better than errors. Incompatible pointer types returning item star from a function with a result type restaurants. Ooh, did I make a, yes, it shouldn't be restaurant pointer, it should be item pointer, my mistake. And then incompatible pointer types assigning, okay, so it's comparing, it's complaining about the other part of that. So now that runs, okay, that worked. Now for the moment of truth. It worked, hooray! So it printed out, this is what we wanted, whoopsie. Printed out, this is, we can get rid of actually this print statement where we're printing out all of the items. But it printed out all of the restaurants like we expected and what they have on the menu. So I just deleted that line. And there, perfect. So what does Tandoori Bowl sells these things, that's on their menu. Domuchibi sells these things, that's what's on their menu. Pom Pom's Tea House has their Thanksgiving sandwich, and Jowry's has their ice cream. Okay, cool. So now the last part, I want to go over how to free all of these items. So we've read them all in. Now let's turn around and free them. So in order to do this, what I really like to do is I would like to also write these as functions. So I would like to make a function called destroy restaurants and pass in restaurants and restaurants. And I'd like to make a function called destroy items where we have items and num items being passed in. That's what I'd like to do. Well, how can I do this? Let's start with destroy restaurants. Sounds so aggressive. Let's start there. So we're going to do the same thing we did with like printing, where we're going to make a loop inside of here. So void destroy restaurants. And we're going to pass in restaurants star star, restaurant star star. Restaurants and an int num restaurants. And then we're going to do the same thing here. We have a for loop. So I equals 0, I is less than num restaurants, I plus plus, and then, okay. And then we'll make a function called destroy restaurant, because remember, destroy restaurant and pass in the individual restaurant, because you might think, oh, well, silly president, all we need to do is just do free restaurants, right? And the answer is no. All this is going to do, remember, all restaurants points to is an array of pointers, an array of values. But what those values, if you do free restaurants, you never actually free the values that it's pointing to. And so you create a memory leak because you're not actually freeing the entire restaurant. You're only freeing the pointers. So like you're only freeing the size of 8 ints. You're not freeing the names. You're not freeing the prices. You're not, I'm sorry, you're not freeing the names. You're not freeing the menus. So that's why we can't just do that yet. So I want to create a function where I'm just going to pass in a restaurant, I, right? And then, so let me declare that function. Now, you might also say, okay, well, you said that we need to free the actual object. So doesn't that mean we can just do this? And no, you shouldn't do that. Because we allocated space for the name, remember we did that whole strdup, and that's going to allocate space for the name. What we actually need to do is do free restaurant name here. And then we can go ahead and do free restaurant. Because if we don't free this, it's again, remember this is just a pointer to a character, because that's what strings are, pointers to character arrays. If we delete just free restaurant, if we do just free restaurant, we'll delete the first character, but the rest of it's going to be left in memory, and that's bad. So we want to make sure that we free the character array as well, that pointer. Then we can free the restaurant. That's fine. So, and I believe that the double will also get freed as part of free restaurant because it's a primitive. It's not actually a pointer to anything. So now after we've destroyed every restaurant individually, we can destroy our list of restaurants. So we can do free restaurants. And this will free the actual array of values that we created, the array of pointers, that is, where we're pointing to each restaurant individually. Okay, so we figured out how to free the restaurants. Now let's write our destroy items. So we're going to pass in the items array. And we'll pass in the number of items. And we'll make it an iterator, or a value to iterate with. Okay, so now we're going to do the same thing. I'm going to make a function called destroy item, and I'm going to pass in items I. So I'm going to destroy each item individually. And what needs to get destroyed when we have an item? Well, we really just the name. Oh, I forgot to destroy the menu here in the restaurants one. Whoops. That will well, this will then destroy the entire restaurant. We need to make sure that we destroy the menu, the entire menu, not just the pointer, the value. We need to free all of that space that we allocated. So here, when we're destroying the item, we really just need to free this name here. Then we can free the item. And then in our destroy items function, we can at last destroy the items array, or free the items array. Okay, and those are our two functions there to free all of the memory. Let's compile. Must use struct tag to refer to items. Ah, I see, 132, line 132. Yes, I keep writing not the type name plural when I don't mean to. Let's compile again. Let's run it. And all of our memory was freed at the end. Okay. And that concludes the programming. That concludes our project. So at this point, does anybody have any questions that they'd like to ask? You can go ahead and unmute yourself and I'll stop the recording.